All right. Well, hey, everyone, and welcome to another edition of Hello Interviews. This is our chance to talk with leading personalities and experts in the industry. Today, I've got the pleasure of talking with Jordan of Jordan Has No Life YouTube channel. If you haven't heard of Jordan Has No Life, you should definitely go check it out. I'll include a link in the description. But Jordan has a huge catalog of both technologies that he's done deep dives on, as well as breakdowns of common problems. But I really wanted to have him on the channel because I really respect the content and I think that he does a great job in explaining things. But also I wanted to talk to him a bit about his journey in learning all of the different topics that he's come into. Jordan, welcome to the channel.
Thanks for having me, Stefan. It's been a pleasure. I've been following Hello Interview for a while, and you guys are doing great stuff as well. So glad to be on here.
Well, I want to start off with kind of an intro. What made you decide to start a system design YouTube channel? What was it that prompted this?
Sure. So I guess I have it kind of in my channel description where the short form of it is at some point I was studying systems design myself. The reason being, so back in my sophomore year of college, I had an interview with HubSpot for an internship. And that was the first time I was ever asked a systems design question. And, it was a pretty simple one. It was design tiny URL. And I just was unable to do anything. I did not really understand how a database worked. I didn't really understand what sharding was or replication or anything like that. I didn't really understand the concept of, certain locking techniques in databases or, not modifying rows in place, but adding new rows to do things like counting. And I came out of that interview and I was like, gosh, I know I'm going to have to learn this eventually. So eventually I'm going to have to get to this. So I finished college basically with a semester early and didn't have anything to do before starting work. So I was like, all right, well, I think, it was a great time. But, besides all the extra drinking that I was doing, I think I spent a lot of time trying to read DDIA or Designing Data Intensive Applications, which is a great book. Highly recommend it by Martin Kleppman. But as I was going through that, it was also super dense. It still took me a really, really long time to get through. And so I was trying to supplement that. I did go cover to cover. Yeah, I've done that twice now and I've taken notes on it. And I think that's really how I got this whole thing started is I read that, I took notes on that, and then I put that on blind because I was like, you know what, this was so dense for me. Maybe I can help some other people by doing this. And so people on the internet were pretty appreciative of that. I was also going on YouTube at the same time, starting to look up actual systems design interview questions. And I felt that a lot of the choices that people were making in the videos weren't really based in any logic from that book or anything like that, but more so just kind of arbitrary reasoning from someone who pretty much all the programming I had done up to this point was based off YouTube tutorials where you're building some website and you're using a Google Firebase database and it takes a minute to spin up. You don't really have to make any decisions. You're not really building anything at scale such that you need to make those decisions. And it was all these pet projects. So I think actually reading a book like that and getting that type of perspective really changed the way that I thought about programming. And then going on YouTube and seeing kind of the videos that people had been putting out in the past to try and explain those decisions, I was like, there's clearly a pretty big lack of depth here between what I read in this book and what I see on the internet. At first I made all these shameless videos just completely ripping off DDIA to try and help explain that. And then eventually I tried to re-implement a lot of the problems that I saw in popular interview books like Rocking the Systems Design Interview and trying to use the logic that I saw in DDIA to build those again.
Very cool. Well, one of the things that I love about your channel is you go into a lot of depth about various technologies. I'd love to actually understand how you learn these topics before you teach them. I think in some sense, being able to teach something is almost a higher bar than being able to apply it because you need to really build a good mental model around it. What's your process for learning?
So I think it kind of started out, like I was saying, with just reading the book that everyone told me to read. And the nice thing about that was right off the bat, that identified tens, if not hundreds of topics that I knew I wasn't getting enough information on and needed to learn more about. And then from there, it was just a matter of okay, I heard about this system. You offhandedly mentioned a system like Cassandra or VoltDB or Kafka or something like that. And it just became a matter of, okay, well, I understand this system exists. I hear plenty of engineers talking about it. Let me go ahead and try and look that up a bit more. So I think when it comes to a new piece of technology, what I find is that when I go to a lot of their official documentation websites, it's really easy to get lost in how many buzzwords they're using. And because at the end of the day, they have to market this technology, even if it's open source. And so I think the actual purpose of it can get lost pretty easily. So I find that actually these 10-minute simple YouTube summaries of a given technology are a really good place to start. And then after that, once you really understand why it exists in the first place, then you can look at the documentation a little bit more or, if they have white papers, that's something I'm trying to get into a bit more recently because I find that to be very helpful. And, just dig into it as much as possible. Like, ChatGPT is also very much your friend in these areas. If someone's written a good amount of text about a piece of technology, it's really good at parsing that and summarizing it for you. So,
And if they haven't, it's good about lying to it.
Exactly. So, yeah, I mean, I feel like, just using the internet and the tools available at your disposal are really good. If you're not willing to Google and try and figure out how something actually works internally, I feel like you're going to have a rough time learning how a new technology might work.
Definitely. Now, this process that you go through, it sounds like you identify topics that you don't understand, you go deeper on them. Would you say you use more of a breadth first or a depth first search as you're going through this? How do you decide when you've gone deep enough?
I think definitely a breadth first search. As much as I would love to do a depth first search, I feel like if I did a depth first search, I never would have gotten to really cover anything. Because when it comes to like databases or distributed systems or anything like that, there's just so much content that's been written about it from literally multiple decades, like starting pretty much in the 70s or the 80s with databases coming out at IBM. And so at the end of the day, I feel like I could really, really try and dig deep into that, but I'm also trying to balance it with being pragmatic and learning about stuff that's going to benefit my career. And I think getting a bit more breadth has been nice as well, because like you mentioned, I'm still fairly early in my career. It's not like I've, completely locked into one particular area. And so I think having a lot of breadth has been useful because it can point me to what I may be interested in working on. It can just give me a lot of high level ideas of, solutions for a problem. And then I can lazily learn about them, right? So if it works, someone says, hey, we want to implement this one thing and, do it with stream processing, rather than being like, okay, well, I know a ton about one particular technology and only rely on that. I think it's better to have a high level understanding of a few different ones and then use that to fuel the deep dive that you eventually do have to take for a specific problem.
Got it. So it sounds like it's curiosity driven, but maybe with this focus on things that are going to be practical for your future career opportunities. Is that accurate?
Yeah, absolutely. Like at work, I recently switched on to like a data engineering team doing software development there. And I think that a lot of the videos that I've been making recently reflect the things that I'm interested in learning about.
Nice.
Definitely a curiosity aspect. And I think work is benefiting my YouTube channel. My YouTube channel is benefiting work. And it's a nice symbiosis to have.
Cool. So you've taken a step back recently. I think you talked a little bit about white papers where you're going to focus more on like deep dives rather than design this system. What motivated that transition? And have you learned in some sense differently now that you're going deeper than kind of this breadth oriented solution design that you had been doing previously?
When I was just trying to build like systems at a really high level and make videos for them, at the end of the day, those are tailored towards a 40-minute systems design interview or a 1 hour systems design interview. And even within my videos, frankly, like I don't know that you could get through all of that in a 40-minute interview. Like when you really try and implement these things, there's so many small details and so many small engineering choices that I glossed over. And the more that I started reading these papers, the more that I came to understand that. And one, I think, good example of it would be partitioning and like dealing with hot partitions. So if you're taking a database and you have to shard it out, so you have multiple different nodes that are representing a subset of the key range, certain percentages of that database are going to get a lot more load than others. And I feel like in most of my systems design reviews, I'm like, okay, well, you might have hot partitions, but just make a bunch of small ones and moving them around as time goes on. And the more that I read these papers, the more I come to understand how challenging of a problem that actually is in practice. Like much of the Amazon DynamoDB paper, for example, is about dealing with hot partitions. And similarly, the original Amazon Dynamo paper is also based around how are we going to move partitions efficiently? How are we going to choose the ranges for our partitions? Things like that. So I think there's a lot of high level details that I came to understand through studying all these very abstract problems. But when you actually really have to jump in and build these things, it gets a lot more complicated than that. And I think working a bit longer and having to like actually come to make some of those decisions myself made me realize that like, wow, I really need to dig deeper at times here because I'm just not thinking of things with enough complexity.
Got it. So I guess through your career, the depth required for you personally actually increased. And as a necessity, this is also the coverage that you brought to the table. Well, Jordan, I think you've covered a lot of ground over the last several years, and it sounds like you've got a pretty good idea of kind of like where you started and where you're at now. Looking back on all your learning that you've done, what advice would you give to people who are relatively new to system design? We have a lot of folks who come to Hello Interview and they've got a system design interview coming up and they've never designed a system at scale. They kind of feel like they're out of their depth already. What would you suggest for them?
Yeah, I don't know if I can give like a be all end all best way to learn, but I think I could definitely give a way that many people do attempt to learn and say it's not the best one, which is to just be like, okay, I've got a systems design interview coming up in a month or something. I've never really done this before, so let me go look up all the common problems and try and figure those out. Because I think that right off the bat, if you're fairly new to thinking about these types of problems, the logic and the reasoning that people give in these videos, if there's any at all, is not really going to reflect. It might be lost on you. So if I choose a particular database and then I give some reason for choosing it, there are certain properties of it that make it better for like a lot of writes or a lot of reads or something like that. And you don't have more prerequisite knowledge there, then I think it could be really tough to understand what's going on in that video. And if your interviewer challenges you, I think you might be in a bit more trouble. So I feel like it helps a lot to go through the quote unquote like fundamental concepts or building blocks of learning that aren't necessarily specific to any one of these particular problems, but are more so specific to all of them or helpful for all of them. Really try and get those down or those fundamentals down. And then from there, try and tackle interviews. So I've tried to formulate the videos on my channel in the same way because at the end of the day, everything that I'm doing on my channel is just a reflection of how I'm learning. I'm not a master of any of these things. And I'm making videos in real time as I'm also trying to learn. And I felt that it helped me a lot to first be like, okay, I'm going to get, the core concepts down of what's in DDIA plus like a little bit more. I think I made some videos on some MIT distributed systems class content as well. And then once I have those down, I think I'll be a lot more prepared to actually go and like tackle interview questions in particular. So it could be DDIA that you read. Maybe that's going to be too dense. Maybe you prefer to read some summary of it. Maybe there's another book that I'm not sure of. If you go on the internet or on Blind, there are a few different books that people talk about where DDIA is probably the most popular one, but just some book that really explains like what a database is, what partitioning is, what replication is, stuff like that.
Yeah, it seems like there's kind of like this top-down approach, which is go and find questions that you're likely to answer and go and see if you can get coverage of them, which is going to be very shallow and brittle. I think it's about the best that you can do in the timing. And then you're talking about this bottoms-up approach where you learn all of the concepts and gradually build. It sounds like actually your own approach has been kind of this middle out, if I can abuse the Silicon Valley association, where you're kind of finding some of the fundamentals, but they're attached to things that you want to learn or that you are trying to solve for. And at least for me, that's been the most effective because I don't know that you can approach system design learning from pure first principles. Obviously, without those foundations, you're not going to be able to make much success. It needs to be grounded in something that you understand and you're going to connect it to. That practical part is so important. And I'm glad to hear that that's also been a common thread throughout your learning.
I totally agree. And I think if I had to add anything else, it would just be, to keep building personal projects on the side because you'll discover concepts that you don't understand and you can kind of tie those into systems design a little bit. So, you'll start to understand why you need a database or why you need something built a certain way. Why you need a couple of application servers instead of just one. So I don't know. I felt that things like that help to really give a lot more context to the whole thing rather than just like learning a bunch of vocabulary terms.
Yeah, I love it. Are there specific personal projects that you've attempted outside of work that you felt were valuable and taught you a lot?
Nothing too crazy since college, for example, but literally so much is like being I'm going to deploy a website and I'm going to have a database and I'm going to have a server to literally understand like, okay, this thing is persistent. This thing is what's answering my application requests. Like for a lot of people when they're going through college and you're writing code, it's just going to be like data structures for the most part or operating systems. And the jump from doing that to actually making like a user facing application is a lot less trivial than looking back. It seems at times like, the first time that I went on YouTube and I was like, how do you build a program in React and have a backend and let people log in? Like that's actually a really big step, I feel like, from what most people are working on in college. And it takes a lot of work to get from point A to point B there.
Definitely. I think one of the challenges with personal projects for a lot of people is just getting to that level of scale that things start to get interesting. So certainly if you've never deployed a website, by all means, but once you get to that spot where you're trying to figure out how to deal with hot shards as an example, or how to scale and distribute load, you oftentimes don't have that problem ready. If you're in a big company, you have it everywhere, but as an individual, you don't. I remember some of my earliest personal projects were actually web scrapers. And my whole goal was, I'm going to assemble a ton of data so that I can try all these cool approaches. I basically need the big data so I can have problems that I can go and test my solutions on. I'm not sure if you had anything similar, but it very much feels like for a lot of personal projects, that is kind of the bottleneck. That's where you'll start to suffer if you don't have a job already where you can test those concepts.
That's a great point. I don't personally, but that's actually a really great idea on your end, is to basically just manufacture them for yourself and mess around. So
Yeah.
I like that a lot.
Well, you've touched on a lot of old tech and some modern stuff. I love the TikTok video. ML system design is one of my sweet spots. I'm wearing my machine learning shirt today, as well as, some ancient pieces. I won't say that Hadoop is ancient, but I remember some of the content that you had around there. I'd love to get an impression from you as someone who's been exposed to, a lot of the history of system design. What are some trends that you're seeing, either things that people used to be doing and are no longer doing, and so, for instance, candidates should try to avoid, or things that you think are hot and are going to be really likely setting the stage for the next few iterations of system design?
Right off the bat, I'm going to caveat this statement with saying who knows, because, despite there being trends, I think there are tons of companies that are doing things in the quote unquote old fashioned way of doing them. So for example, my company is still running Hadoop on-prem, and that's the underlying object store for all of our data. So
wait, HDFS or what is this?
HDFS, yes.
No, HDFS is great. Battle tested.
Battle tested, exactly. The first one I'm going to say maybe is using more of these like stateful consumer technologies. And to be clear, like this isn't something that arose yesterday. Like this has been happening for a while, but I feel like just the number of people who are like, I've never heard of anyone using like Spark structured streaming or Flink very much. And I don't know, it seems pretty cool to me. And it definitely seems like it's being used more and more in production systems, as opposed to just like building your own consumer and then, building your own replay mechanism of persisting state to some data store on your own. So I think that's maybe one of them. Again, not super new, but just has to be done. A lot of these are going to be kind of focused on the analytics space, because I think that's where I'm finding a lot of my passion these days. But just, like columnar storage as opposed to row-based stuff, you'd be surprised, but like Spark operates on row to row. And that's funny because, it's a big data tool. And so it should be operating on, individual entries, one column at a time to speed things up. So there are a lot of, projects going on to make that happen. We kind of touched upon this already, but just the concept of the separate scaling between storage and compute in cloud databases, putting all these files in S3 and then having a separate compute layer, because CPU is now the bottleneck as opposed to network. So pulling a bunch of Parquet files out of S3 is not too bad. I think this one is more of an ode to some of the OG database guys, but I guess it seems like, well, I don't know. Maybe this is less true in practice. I feel like NoSQL is losing some steam. Maybe I'm wrong about that. And I feel like everyone's just like, okay, yeah, SQL's good again. But maybe I'm wrong there. Like I've got very few examples to say that. I'm just basing this off what I see at my current company and things like that.
Is it the vibes of the people that you're hearing?
I think so. So, and if we actually want to go like last like 3 to 4 years as opposed to like last 10 years, I would say something like Iceberg, open table formats, Iceberg, Hootie, Delta Lake. And instead of running all these Hive tables, it just saves you a lot of time in terms of listing all the, different files of the table, allows you to update your metadata transactionally, which is very, very useful. A lot of benefits there. I think the Arrow project is insanely impactful, or at least has the potential to be. Having one standardized format to communicate columnar data, both in memory and over the network, is massively popular. It's great for doing data science with Python or like polars, great for sending data over the network from, say, one data warehouse over to another for more processing. I think Arrow is just really, really cool in general. And then the last one I'm going to give you your flowers on because I think you've really opened up my mind more to this is maybe you don't have to distribute stuff all the time. Maybe CPUs are just getting good enough and you can run shit on, one node, and that's okay.
Massive hosts.
Exactly. And vertical scaling is back. Tons of cool projects going on out there. I really know nothing about the machine learning space, but I think a lot of these are starting to be integrated there, because effectively that's always just going to be a big data bottleneck as well.
You hit on a lot of cool stuff there. I love the stateful streaming approaches. They've basically taken a lot of best practices that have been accumulated over the years and put them in nice frameworks that you can use. I think Flink is a great example of this. And then all of the examples that you've given so far are Apache projects. It's been crazy to watch how effective Apache has been at incubating good ideas and then giving them standard status that can be used. I think Iceberg is the perfect example of this, where you've got so many vendors in the big data space, but having an open source, reasonably open standard that everyone can integrate with means that, the floor raises. And that's probably how we should expect technology to evolve for, decades to come.
It's great to see everything just getting more open as well, like you said, because the less vendor lock-in that you have, the better. If you're using Iceberg as your metadata layer, you can switch between types of query executors that you're using, so you're not necessarily locked into Trino or Spark or Flink or anything like that, which is great.
Perfect. So I want to kind of put you on the spot. I'd love to hear about your opinion on databases, and let me just kind of set the stage. Like, as a generalist software engineer who might be put on kind of any problem space, and you want to be able to be effective in any of them, what would you say are like your top 4 databases? Maybe the top 4 categories, and then who's the leading contender?
Oh, top 4 categories is tough. Oh man, I was gonna say I'm almost like a little bothered by this question, because I think that who knows what a top database is, but more so just
No, you have to answer
everything. I have to answer.
This is my channel.
Fair enough. You're going to have to kick me off. It's going to be like Zelensky yesterday. But anyway, point is, I don't know that there's really ever necessarily a top database. I think there's a top database for a given situation, and it's not even necessarily based off performance. Every company has their own standards. There's operational know-how that's built up between the people working there. And sometimes the best database for the task is going to be the one that you already know how to use or have tools built around. And so I think in your last question, I mentioned a bunch of databases that I personally am really interested in, or I think are great. And I'll toss in like whatever. Spanner is always going to be great. There's a bunch of stuff like that for transactional stuff, but it's probably expensive. So everything has pros and cons. And I think that looking at your specific organizational structure, what you're able to spend, how realistic things are to deploy is just as important as like random performance characteristics of a given database. And I think that's another thing is, as much as you can make all of these hypothetical statements in a systems design interview where you have an idealized problem where, you can pick whatever database and just be like, we're going to use this one. The reality of the situation is, what your organization is comfortable with, maybe the cloud vendors that they already have deals with or things like that are also just going to take major precedent when it comes to making a data store choice.
Yeah, definitely. Tons of trade-offs to navigate, and a lot of the constraints are completely outside your control. There's not really an optimal in some sense. This is actually a good lesson in general for people who are entering system design interviews, is that there isn't a right answer to almost any question. I think definitely some of our audience got the impression that there is some optimal solution, and the reality is there's not. There's just trade-offs all the way down, and there's obviously a Pareto frontier. You can make a bad choice, but the best one is oftentimes ill-defined. So I actually love the fact that you deferred on the question here.
Yeah, and I think the biggest thing is you don't want to build and put engineering hours into scale that you don't need as well. So like you mentioned, everything could possibly just be handled with one Postgres database, and then life is good and you don't need to make all these crazy decisions. So it's really only when you're at the frontier of optimizing stuff that things get super crazy, I think, a lot of the times. And sometimes life can be pretty simple, which is nice.
Yeah, well, and simplicity is your friend as a software engineer. Of course, companies always like to interview for that talent that's going to lead the charge when they are at that frontier and they want to go and try that new problem that no one solved before. But I think for the reality of most engineers, they're solving problems that are reasonably common, and there are some good solutions that are already out there. So choose some boring stuff because it's going to work out pretty well for you. To that end, I'm going to maybe flip a bit and be less practical, but I'd love to hear what has been the most interesting system that you've covered recently, or the most interesting technology. I think, there's obviously a lot of very useful technologies, some that have very broad appeal, but just from like pure learning or new concepts that are being brought to the table, what would you say maybe over the past 6 months to a year have you covered that you would say tops the list?
Sure. Well, I guess I would maybe split this into 2 categories. I think there were like the best reads in terms of papers because they're, well written and fairly easy to understand. I think, most engineers, regardless of how much thought they've put into distributed systems, could understand them. So for that, I think I would give the Kafka and the Flink paper a pretty big shout out, just because there's no like crazy compiler optimizations that they're doing, or at least they're not really touching upon them. All the terms are pretty easy to look up and figure out what's going on. They're not super long papers. Super common technologies as well. And I think that's part of the reason that I feel so like evangelized by both of those technologies. It's just like really nice papers and easy to consume as a reader and understand why they're so special. A lot of people are using them. In terms of just like projects I'm excited about, I was getting at this one a bit, but the whole Arrow ecosystem in general, I guess if I dive into it for like a minute, basically it is a standardized memory format for representing columnar data. So rather than representing your data in row by row and basically having A, B, C next to one another, where A, B, and C are all different entries in the same row, you would basically have A1, A2, A3, B1, B2, B3, where those are different columns. It'll compress things for you using tactics like dictionary and run length encoding. And, not only do you have a standardized format in memory, which is really nice for passing data from one process to another on the same machine, but you've also got arrow flight, which does the same exact thing, except it's passing data over the network without doing any extra serialization or deserialization or copying. So it's making things really efficient. A lot of tooling is getting built around it. And I think it's going to be very exciting in the big data space in the next few years.
Super cool. Yeah, the idea of not copying data. I don't think people realize until you actually go and look at the implementations of a lot of these technologies, how many copies are created, especially during network calls. And it can usually be the biggest bottleneck for the performance of a lot of these systems.
Absolutely.
Awesome.
Plenty of benchmarking went into that. And now they have this great tool.
Got it. I want to talk a little bit about career and how your learning has intersected with, your real job. I think there's this impression from some engineers that, I'm not going to be designing large scale systems all the time, or maybe my work is mostly code and bug fixes, on-call issues, as opposed to design, which I might do once in a blue moon. Have you found that to be true for you personally? And then where have you found like the knowledge that you've accrued, both as the creation of your channel and just your personal curiosity, come to be kind of most effective in you doing your job?
I guess I'll have to take a trip down memory lane for a second and I guess outline what I've done in work. So I started out my career working at Google, again, as a software engineer on like a data analytics team or a data engineering team. So building a lot of pipelines. But right off the bat there, I think when you're working an environment that's handling a lot of data and you're trying to write efficient pipelines, having an understanding of what things like data locality and co-located joins and indices really do for you is hugely impactful. I was really fortunate that Google gave us a great set of profiling tools to determine what was making a query slow, or at least identify where the bottlenecks were in a given piece of code that I had wrote. And I feel like, having these kind of fundamentals of just how big data and databases works in general, why it helps you to sort certain pieces of data, why it helps you to partition your data on a certain key, massively helped me to build things that were more efficient. And then also I even had people who were higher levels on my team that, were less familiar with these areas as well. And I was able to help them out with it as well. So I felt like I was already able to make a pretty big impact off the bat, and I was able to present to my team. I think there were a lot of huge benefits there. At my current job in prop trading, I think it's more of a situation where it's like, if you want to seek out roles where you're doing more architecture related stuff, you certainly can. I think there are a lot of areas where it's more so just, about writing clean code and functional code than it is about distributed architecture. But at the same time, I think because there are a lot of people who have spent more time focusing on that, it's also something that has at time been neglected. And so I've been able to identify certain areas of our code base where I felt like we could be making better architectural decisions in terms of which technology we use or in terms of data distribution or something like that. And I feel like it's allowed me to pursue some really interesting opportunities in my company and then jump around different teams as a result and kind of continue to pursue these passions. So in general, maybe it's not always going to be the case that every engineer at, these FAANG companies or whatever is going to be working on distributed systems. I mean, tons of, mobile designers, front-end designers, all this other stuff, and just like normal backends as well that aren't huge tools. But I also think that, these problems are very common at these companies and you can totally seek them out and work on them if you want to and you find them interesting.
Yeah, I like the contrast there also, and you kind of making this part of your job versus this being implicitly part of your job. I'm kind of curious how you avoid this trap that I find, at least from a career perspective, some engineers find themselves in, where they're in some sense making or creating problems and solutions that maybe don't need to exist. I've certainly been guilty of this in my career, writing a bunch of interesting code to solve problems that probably weren't the most important things to be solved by the business. How do you keep yourself honest? How do you deal with the problems that you actually need to solve in order to be effective and to make your team successful, while also applying interesting things where they're going to be most valuable?
Yeah, that's a great question. Admittedly, there have been times where I haven't, right? And, I've tried to really over-engineer something because I'm passionate about it and I'm excited. And I think that's when, as someone who's more junior, it's really helpful to have people with a bit more experience on the team who can be like, listen, what you're doing sounds really
Chill.
interesting and I think it'll work well, but the bottom line is this just isn't going to help us make any money. And that's fair. And I can respect that. I think as time goes on, I'm starting to get a bit more of a sense for this myself. And to be honest, the way I kind of try and keep it in my head is just like reminding myself that I'm lazy and being like, well, would I want to waste my own developer hours on this if I can get it done with a lot less code or a lot less time, or, make a more simple solution to this problem. And also, it's one thing when you're just over engineering something on your own because you want to, but when you're I wouldn't say victim's not the right term, but when you encounter someone else's over engineering, I think it really shifts your perspective on it. You're like, wait a second, maybe this makes me reevaluate my own work and think about what I could have done a little bit more simply, such that other engineers come along and have an easier time reading my code and maintaining it.
There you go. Yeah, you look at the Git commit history and you say, Sarah must have been really bored in 2023. I wish her boss would have given her something more interesting to work on.
Exactly. So, you find something from 4 years ago and you're just like, geez, this is really impressive. But at the same time, why'd you do this?
I kind of hate you for this. Yeah, it's definitely a bit of a mixed bag. Awesome. Well, I've got one more question for you. And you'd mentioned ChatGPT earlier and using it in an educational capacity, but I'm curious to get your perspective on the impact that AI will have on system design and that part of the software engineer's role into the future. Do you find yourself being able to rely on AI for some of the higher level questions that you encounter practically? And do you find it to be useful in answering deeper, more reasoning heavy or trade-off heavy questions, especially as you do these deep dives?
Right now, at least in my day-to-day workflow, AI has been really, really nice in terms of just being like an enhanced search engine for me and, parsing existing documentation. I think it's not gotten to the point, at least in my experience using, ChatGPT 4.0. I don't think it's gotten to the point that I would just be like, hey, what's the best design to go implement this problem? Because like I was, alluding to before, that is very much not a question that can be answered by someone without any actual organizational and practical context within your company. You have to go talk to other people, see what your existing, situation is, what your relationships are with certain companies in terms of, what you can actually pay for, what you can't pay for, what you have to deploy open source, or how many resources you have available, or how much other departments are willing to pay for you to implement this service. And I mean, in theory, maybe you could pipe all that information into ChatGPT, but just practically, it can't do it on its own with a quick question. You have to do a ton of speaking to other people and really flesh out practical requirements in order to build real systems, as opposed to, asking it high level trade-offs. I also think that even in terms of something like, in theory, take a database like Cassandra, that's really nice for write speeds because it uses an LSM tree. I think it does understand that part, but then I feel like it may have trouble synthesizing, well, how does that make it compared to MongoDB if we were to choose that instead for this problem? Maybe if someone really formally tried to outline these things in a very easy to parse way on one document, it could do so and then spit that logic out. But again, that's all conceptual. It's easy to say in an interview, but it doesn't really mean anything until you actually go and benchmark stuff. All this high level kind of hand wavy stuff that I like to say in my interview videos, it doesn't really matter because, maybe someone just wrote better code than someone else. And so despite using a different engine type, that database is slower. So at the end of the day, I feel like, maybe you can be skeptical of things that it says, but you're just going to have to verify them at the end of the day. And you also have to make practical decisions to get systems that actually work for your user base and, within your organization.
I think there's some practical takeaways for that as well. You mentioned both there not usually being an optimal answer, a bunch of trade-offs, but also that the context was incredibly important to the decisions that you're making. And if you think about that as an engineer, one of the key ways that you're adding value is that you're internalizing all of those pieces. And that has always been important, but it seems increasingly important as the tooling changes.
Yeah, and it's something also that I feel like I've become more privy to, especially the older I get and, the more years I get under my belt, is just at the end of the day, you probably have stakeholders and making sure they're really aligned with everything you're doing is also very important. So, maybe ChatGPT can go and suggest you some system, but if your stakeholders have never heard of it and they're not interested in it, that doesn't really much matter. So there are definitely a lot of practical concerns that come up when trying to build real systems. And I think that, like you mentioned, synthesis of all these distinct sets of information and navigating not only the technical challenges here, but also the interpersonal challenges are very real.
Well, Jordan, this has been incredibly insightful. I like how we covered both your career journey and then how a lot of your learning, you were able to basically broadcast this outward, but you're able to integrate this into the career path that you've chosen. And I also like some of the thinking that you had and how it's evolved over the depth that you're covering, but also the practical reality that there's no optimal solutions and there's a lot of trade-offs. And part of your job as an engineer is to build content. Some of those things are important for system design interviews, like especially at the staff level. These are things that your interviewer is going to be looking for. Do you recognize that these are contextual? And some of them will only be important when you actually get on the job, just because you're right. A 40-minute interview necessarily can't cover all of the details that are therein. So super grateful for you spending the time with us. And yeah, I will drop Jordan's channel into the description. If you haven't subscribed, I'd highly recommend it. Awesome videos coming out. Is it on a weekly basis? You seem to be pumping them out pretty frequently.
I attempted to do weekly. Yeah, we'll see. It may drive me insane soon, but we're still doing weekly for the moment.
That's impressive. Awesome.
Thanks,
Well,
Stefan. I
Jordan,
appreciate it.
yeah, thanks again. Talk to you later.
Yeah, thanks for having me.